Good morning, everyone. This is Joe Falkley, Product Director at Gallus, and I'll be presenting an introduction to CM manufacturing. And what that's about is reducing costs, saving time, and winning more business with the utilization of the tool. Now, what you need to understand is that without doing detailed estimates on the parts that you procure or make in-house, there's no way that you will really know what you should be paying. So should cost is most important. And unfortunately, most organizations go by previous purchases where they do an analogy based on what they've paid in the past for what they should pay in the future. And the pitfall of that is that you may be paying too much for some of them and getting a deal on other ones. And you don't know which ones are which, and there's no way that you go into a negotiation prepared, because you're basing it on what you've paid in the past, which may have nothing to do with the value of what you're trying to buy. So going by previous purchases really can be hazardous to your bottom line. And if you simply employ CM manufacturing to produce in-depth accurate manufacturing estimates for any of your procured new design or build-in-house parts, you'll be far and away ahead of any other organization that's not doing that. As far as the company is concerned, we produce 4 major products, one for estimating software, another one we call a CFRIT for information technology, and we have a top-down life cycle hardware model called SEER for hardware. And then what we're going to be talking about today are in-depth manufacturing model, SEER for manufacturing. And as I said before, the SEER-H, the hardware model, can be utilized early on with very little information because it is a parametric model and it works what we call top-down. In the manufacturing model, works the opposite way. It works from the bottoms up. And it is a process-based model where you stack processes together to get part answers. This chart represents our tools, the software, the hardware, the IT model, and the manufacturing model. But what I want you to take away from it, first of all, is that H is the cornerstone where all your estimates can reside. So you can start out with target cost estimating in H, and you can utilize all the other models and attach those estimates. In the case of manufacturing, you actually replace the parametric estimate in H with the manufacturing detailed estimate and utilize that to start a new program off, put your target cost together, go out and do trade studies in the manufacturing model, and then for your high-risk, high-value items, and put a proposal together that's based on parametrics and bottoms-up in order to accomplish the task. The other thing that I'd like you to take away from this chart is that it tries to envision the fact that we have an API, an automated, application programming interface, simple to use, comes with the model, no extra cost, it's part of our tool, where you can have any input or any output can be driven into the tool, so you don't have to type in a WBS or the bill of material. It can be imported from an Excel sheet or Word, whatever kind of document that you have that's ODBC compliant. And also, any input or any output can be exported out of the tool. What does this do? This allows you to automate the estimating process so that you can update it automatically. If you have links to engineering database, you can work with other softwares and utilize the tool to, again, automate the estimating process. Most important. Some of the things that we do have, like this SEER of the client for MS Project or Microsoft Project, with a couple of keystrokes, once you have an SEM or an IT estimate, you can develop a detailed Microsoft project plan with no problem at all. One of the things that differentiates us from all other tools out there is the fact that we give you a point estimate, but we also give you a range of cost. Within the tool, we ask you for 3 inputs where it makes sense, for least, likely, and most. The likely, the center entry, is your expected value, what you know today. On the left, the least, you couldn't imagine it being any less than that value. And on the right, you wouldn't expect it to be any more than that. Once you enter those 3 entries, the model takes the least plus 4 times the likely plus the most, divides by 6, and gives you your triangulation of that number, gives you the point estimate. But it also gives you a range of cost. That range of cost is very important, especially to management and you. How many times have you walked into the manager's office and he's asked you, or she's asked you, how confident are you in your estimate? Well, now you can allow the model to give you an output, this chart, to show management the maturity of the estimate. Basically, the flatter this line, the more mature it is, because the more knowledge that you have and things that you're not unsure of would flatten this line. The more things that you're unsure of, the more skewed this line would be. So once you point that out to management, they'll know the maturity of your estimate, and they'll also be able to pick a confidence level so that they make the decision on how much risk the organization is going to take going forward with the estimate as it is, or they may send you back to update it or try to get more engineering information or whatever is lacking in order to put a flatter line and a more mature estimate together. The manufacturing model is made up of 2 components. We have basic processes, and we also have an Aero plugin. The Aero plugin was designed and built by the aerospace industry in the U.S., and the major OEMs were all involved in that. Boeing, Lockheed, Northrop Grumman, GE Aircraft Engines, and the Air Force and the Navy were all involved in putting that together. You can use both the basic and the Aero plugin for aerospace work or non-aerospace work, because there is a setting called product classification, which you can set for the type of work that you're doing, whether it be commercial work, consumer work, or aerospace type work. Here are some of the common uses for our tool, the manufacturing tool. And under cost reduction activities, should cost estimation absolutely goes at the top. Procurement support, negotiation support also, as well as value analysis. Trade-off analysis, so that as you're building a design, you can come up with alternatives and figure out which ones are the most viable as far as cost is concerned, and then make decisions based on that. Simple things like understanding where the cost is. Is it in a material or is it in the labor? Maybe it's in the tools. Having that knowledge fortifies the understanding of putting those costs together and doing the trade studies, and then being able to do adjustments so that you can get a more leaner answer, if you will, for the things that you're trying to design and build. Supplier differences. You can start to understand what the differences are, because you can set the model for automated shop or a non-automated shop and look at those kinds of differences. As far as business management is concerned, it will help you do make-buy decisions, design to cost, maybe the cost of a change. You want to do a change-up or something in a factory, you can do that. Earn value analysis. You can see where you are in the project. Staffing profiles can be produced utilizing the output of the model, because it's going to give you total hours, etc. Equipment utilization. We have a pricing scenario, actually a rate generator that looks at where you can put in the cost of the equipment and do an ABC accounting. Supplier partnerships, lead time reduction, improved estimation and quality policy for CMMI departmental procedures will certainly be enhanced utilizing the tool. And as I said, should cost really is the cornerstone of any company that outsources manufacturing or wants to evaluate whether you want to outsource or do it in-house. And our model, the CM manufacturing model, gives you that capability because it provides credible and defendable estimates, allows for the evaluation of alternatives, and you facilitates proactive real-time cost impact. In other words, you can sit down in a conference room with the engineering staff, the design staff, manufacturing engineers, and cost people, and thrash through a couple of designs and understand what those costs are, where the costs are coming from, and then as a group make a decision. It really, really enhances that process. And you can do that before you cut a chip. It facilitates vendor negotiations really by allowing you to sit down with the vendor and say, look, we assume that you're going to do this, this, and this. And they can come back and say, yes, we'll do that, but we don't do this. We do it a little different way. We use this type of machine. You can adjust the model. And negotiation becomes somewhat of a moot point because you can agree that this is what it's going to cost to make it based on the model steps. What is CM manufacturing? It's a bottoms-up parametric cost model. It's based on time and motion study standards, MTN type standards. For IEs in a group, what we have, we're utilizing type 2 because they were developed as type 1 standards, but because they're not used on the parts that were time studied, they become type 2 standards. We do parametric forecasting within the tool, and let me explain that. Basically, if we've collected standards, let's say a welding, to weld 1 inch of a weld seam, maybe 2 inches, maybe we collected 3, 5, 7, 9, infinitum. And what we do is we'll connect those dots using a least squares projection. And if a user comes in and wants to know what the cost of 2.5 inches of weld is, the model will report that out based on that parametric forecast in between the 2 and 3 inch absolute time study that we have. It reports, the model reports at the process, part, or project level, depending on how the user sets up the tool. Out of the box, its goal is to give you average production unit cost, APUC. It estimates labor, material, and tooling. Now, it bases the estimate on many, many things. The part size, of course, the process that you're in, the steps within that process. But it looks at things like your production quantity and your batch size so that you set the setup amortizations to accommodate the setup cost, and it's amortized over the right quantity. And those lot sizes can be utilized in curves. You can have multiple curves as far as the model is concerned. So the model is very, very finite as far as developing its cost. It performs and provides the design team or anybody using the tool with the ability to start to make decisions very early on. You have to make some reaches when you're early on because a manufacturing engineer would have to say, well, yeah, I think we're going to build it in this machine and so on and so forth. But it certainly can be done. And you can output the estimates in a variety of formats, your choice. Now, these icons on the right, as I said, we have a basic part of the model, an Aero plugin, and these can work together, and they do work together if you purchase both the basic and the plugin. And we do have customers where we make custom plugins for them. It might be a process that they are the only ones that master and use, and we deliver it to them only. I want you to make you aware of the fact that there are many of our customers that connect to their engineering desktop and utilize CAD models such as CATIA, UG, ProE, etc. And what happens is that they send the data from ProE via flat file into our tool using that API I talked about before. It turns the crank, creates an estimate, and sends the estimate back to the engineering workstation. And like I said, we have customers that are doing this today and accomplishing this work. And it really is a time saver. Now, what does it estimate? What does steel manufacturing estimate? It estimates the total and average project, as well as the unit production cost, and it looks at part labor, tooling, and material cost. It breaks up those costs into setup, run, rework, inspection, and material, as well as tooling. Tooling is broken down into design, fab, and material. The material is a cost, and all of the inspection, rework, run, and setup are all labor costs. Now, included in all the processes when you utilize the tool, you can apply learning curve analysis on multi-lots and any curves that you choose. And they can be unit, in other words, percentage curves that you want, and they can be set for unit or cum average learning. As far as labor rates are concerned, the user can enter their own labor rates, or they can utilize our built-in labor rate generator. The labor rate generator is based on inputs that are visible to the user, that can be adjusted by the user, and the user can develop and save their own labor rates for a particular vendor or in-house situation, etc. They include the things like the machinery cost, all of the company type labor expenses, etc., salesmen, and all the other things that you would expect to see in a rate generator are in there, and they can be altered by the user on the fly and saved by the user and utilized. The other thing I'd like to point out is that you can work in any currency you want. So any world currency is usable. You can develop an estimate with multi-currencies in it, so that one element within your project could be worked in dollars, another one in euros, another one in pounds, etc., and the model will accept those inputs. Your tooling costs are developed for tools that are part-specific tools. We don't do expendables and those kinds of things are not done in the manufacturing tool. But part-specific tools are utilized. And what happens is that the model will create, the user gets to set the complexity and etc. And then the model will generate an output. The user can pick the tools that they want, or they can use a default setting and get a tooling cost from the default. And it generates the tool design, tool fab, and the tooling material cost. Also built in is part marking and implant packaging. So you can do any kind of markings or packaging for implant. It also covers non-destructive testing, in-process and inspection and rework done by the mechanic, quality assurance and official rework. This all can be set up so it's how your company works. If your inspectors do the bulk of the work, you can set it up that way, or if your mechanics do the bulk of the in-process and inspection, you can set it up that way. It also includes inspection delay, that idle time waiting for inspection to come. Now, the way you create an estimate is use elements, and these elements I'm going to explain and show you what they are. Basically, we have roll-up, and it's a element that aggregates the cost. It is the only one that can have a child, so that when you produce an estimate, what you would do is, let's say I want an example would be a machine part. I would insert a roll-up, label it machine part XYZ 123, whatever the number is, and then underneath that, I would subordinate. I might have a forging model, my mold cast and forge model. Maybe I starts out as a forging. Then I might have a machining process where I do all my machining steps. And then lastly, a finish model where I might shot peen or anodize or heat treat, whatever has to be done to the machine part to finish it. Those three processes would aggregate their cost into the roll-up to give you the total for that machine part. If you have any purchase parts in your estimate and you want to account for them, what you can do is insert a purchase part model, and you can list your bill of material as far as purchase parts are concerned. We do have an element called additional items, where if this is really for throughput or known cost, you can add time, any labor type, time or material, in order to fortify your estimate with something that's coming in from the outside. It could be supplied by someone else or whatever it is. We also have what we call custom calculation templates. This is a way where you can attach an Excel sheet to any one of our processes, add cost categories up to 10, and you can add parameters so that you can utilize the power of Excel to do any math that you want to calculate custom costs, whatever they might be. It could be a process or a process step that we don't cover within the tool. You can utilize that in order to accomplish that process and incorporate it into your estimate. Now, I'm going to skip by this eye chart, and I'm going to show you the processes. These are all, the ones I'm going to show you now are all in the basic model. Now, we cover machining, all aspects of machining, whether it be milling or turning, threading. We cover things like lapping and honing, also wire winding, kellering, all of the kinds of, whether it be grinding, any and all of the machine processes that you can think of, we've included in the machining model. And also, you can utilize the machining model in two ways. In a very simple way, where you just tell us, how much material is coming away, and the picking operation tell them how much material is coming away, and the model does all the work for you. Or you can press the details button and put things in like the axial depth of cut, the radial depth of cut, all your speeds and feeds there. You can actually pick machines, change machinability. You can do whatever you want to do an absolute detailed estimate on your machine parts. Mold, cast, and forge, we cover injection molding, investment castings, forgings, powdered metals, any and all of the things that you would expect in mold, cast, and forge. In the finish model, we cover things like shot peen, buff and polish, vapor degrease, electroplate, heat treat, anodize, abrasive blast, whether it be with ice or pellets or glass or whatever it might be. So any and all your finishing processes are there. The PC board model covers the development or the building of the board itself and the placement of the components on the board, so that those kinds of estimates can be generated. The electrical assembly is for cables and harnesses. You can do a wire-by-wire estimate on a cable assembly. We do have a process called composites. It was one of our first forays into the composite world in the model. It covers hand layup, film and winding, pultrusion, and composite spray. It gives you a total output. It doesn't really break down the process steps, etc. And it is simplistic, if you will, but it does give you answers for composites. We also developed a detailed composites model working with the Airbus Industries for hand layup, automated tape lay, LRI, and resin transfer molding, resin film infusion. And this was a collaboration with Airbus and made to their specifications for them in order to do these processes. Part of the basic model is mechanical assembly, where you can utilize that for spot welding or mechanical assembly, etc. Brazing, adhesive bonding. The fabrication model does things like shears, breaks, punches, transfer dies, those kinds of things in order to develop sheet type parts. And we do have a tube fab weld and processing model where you can do individual tubes, or you can do manifolds or multiple tubes, weld them up, bend them, weld them, persuasion, whatever kind of process you can imagine is in the tube model, that we have that covered, and we can put that together for you. Now, as far as the Aero plug-in is concerned, what we've done here is we've covered the composites area. First process I'm going to show you is braiding. And the braiding process typically is a vendor type process. But if you want to know what that vendor should be charging you can come up with the cost. We do cover all aspects of hand layup, handle all the material types, cloth, tape, pre-preg, dry, whatever it might be. All the cutting aspects, hand cutting, Gerber knife, water jet, ultrasonic, etc. We also do laser location, locating processes, and so on. We can, in the model, can handle sandwich type structure and any and all aspects of any layup that you might have, whether it be hand. In this case, we have P4A, which is programmable powder preform process, which is a chopped fiber laid on a vacuumized screen, consolidated, and then sent into a mold, a two-part mold where it would be injected with resin and cured. Here's some examples of those types of parts. We also cover ATLM, CTLM, and toe placement, automatic tape play, contour tape play, and the toe placement machines of today. So that any and all of those can be done. You enter the bandwidth, and you have a speed that you can put in on inches per minute, ply by ply. You can do a very detailed estimate as far as those are concerned. I got some examples of toe placement. The seal-on shroud. We have also included 3D weaving. Again, this would be typically a vendor-type process where you can have three-dimensional parts woven for you that would be injected with resin and then cured, so that you can come up with those vendor costs before you go out for those quotes. Filament winding for mandrel-type winding of fiber on process. And then we have cure, whether it be autoclave, E-beam, using the energy from the E-beam to cure, either locally or the total part. We also cover resin transfer molding, where this process is to put a preform into a two-part tool, inject it with the resin, hold it under a cure cycle and heat it up and cure it, and then demold it, take it apart. We also have vacuum-assisted resin transfer molding, which is a one-sided tool. So if you're not making lots of parts, this is an option that may make the part viable because you only have to produce half the tool and half the tool cost, the tooling cost. And you can see in this time-lapse picture what the process is about. After it's been laid up and bagged, they're actually injecting it with resin. You can see over the time it's getting more and more filled. Once it gets filled, then it would either be sent to it would be put in the autoclave and cured, whatever heat source or an oven, depending on what kind of material and resin you're using. Trimming of the parts, essential on composite parts especially, or any metallic parts if they have to be trimmed. But typically composite parts are made non-net, and then they will trim it finally after they've been cured. If you have assemblies to do, you would utilize our fit-up, drill, and fasten modules. The fit-up concentrates on giving you the cost for the part placement, whether they be tube assemblies or machine parts, tool accessories, sub-assemblies, cables, could be a wire harness, whatever you're putting in into your assembly, you can locate. It gives you, also handles hard shimming and any of your bonding type operations like fang surface seal, water sealing, form and place gaskets, all of the kinds of bonding type operations that we do on aerospace assemblies. The drill operation, you can do Drive-matic or whether Jobs type automated drilling or any kind of hand drilling, countersink, counterbore, dimple, all of the kinds of things that you have to do in an aerospace assembly. And the fasten model gives you the insertion, the cost of the fasteners. You select the type and how they're being installed, whether they're being installed wet, torqued, etc. and it'll give you the cost, whether you might be putting in clip-ons or pro seals, etc., and it'll utilize that. You can see the drilling types that we cover and types of fasteners examples. Now, the Aero sheet metal model covers all of the fabrication type work for Aero, and this was put together based on forming processes. What we did was we took over 500,000 part base sample and then drove out costs for sheet metal parts, because we've been doing them for 50 years in the aerospace industry. And all the user has to do here is tell me what the preform operations, like you're going to drill route NC or just drill route, etc. The forming operations, whether it be drop hammer or hydroform, etc. Maybe you stretch the part so you have an afterform operation where you trim the part, and any finishing operations, whether it be 10 mil, prep for bond if you're doing metal bond type operations, primer, paint, whatever your finishes are, and you'll get an answer very quickly and very simply for any sheet metal parts you have in the aerospace arena. Aero paste bonding, where if you have any bonding to do, rather than riveting things together, if you're gluing things together, this is a good model for those kinds of applications. 3D reinforcement is used on dry fiber, where they actually stitch the fibers to make it stronger before they inject it with resin and cure it. And also Z-ping, which stops crack migrations for cured, after the parts are cured and in service, it'll stop any migration of cracks. And last but not least, we have the Aero plugin has the superplastic forming and diffusion bonding, so that whether you're doing this process in-house or going to a vendor for it, you can develop estimates, whether they be packs or single sheet type forming operation. This is an inert gas heated up to a high temperature. They do titanium at about 1200 degrees, and they blow it with inert gas to form it into the model. You can see these right here, the process steps as it's working. That's a simple sheet forming, all right? The model itself is like, if you've used any of our other models, the user interface is the same. It's a 4-window affair. The top 2 are input windows. This is your work elements, WBS, bill of material. These are the parameters that you would put in to give you the estimate. We call this the parameter view. And then down at the bottom, you have outputs. You have reports on the left and charts on the right. Now, understand that, again, you can export any data. So if we don't make a chart that you like, you can export the data to Excel or make any type of chart that you want. As far as reports are concerned, the user can make custom reports. The option is built right into the tool, so you can make option reports. You can send it to a file or whatever you'd like to do with it. Here are some of the users of the manufacturing tool today, and it's quite a list. Now, what I'd like everyone to understand that if anyone requires a live demo, they need to contact us at Gallery and let us know so that we can do that for you. And I can show you how the model works, etc., if you have curiosity about it. And give us a call or write us an email, and we'll be more than happy to take care of it. If there are any questions, I'll take them now. Thank you very much for your kind attention.